And welcome everyone to our Data Science Friday seminar series. I'm really delighted to introduce my colleague, Dr. Albert Kim, who's going to give us a seminar today on COVID-19 pandemic data and data analysis and forecasting for Hawaii's counties. So this is going to be super interesting. Dr. Kim is a professor of civil and environmental engineering at Mānoa with areas of research that include environmental soft matter physics, theory and simulation, computational environmental engineering, member separation processes, and the hydrodynamics of colloids and nanoparticles. Wow, that's a lot.
That's a lot, yeah. That's my.
Anyway, we're delighted to have you talk to the group here. Really exciting topic. So welcome. Please take it away.
Right. Thank you so much. And the slide is on. So I have 59, almost 60 slides, but probably 1/3 of them at least are kind of images. So this one won't be too long. And first of all, when this COVID-19 issues were important for United States, that is, if I remember correctly, sometime in the March. And as like previously theoretical physicists and applied mathematicians who are doing research in computational environmental engineering, I looked through the data, and the data looks very interesting. I mean, sadly, it is interesting. So I started looking at the download and looking at the data. And this summertime that we have NHSEMP called the Native Hawaiian Science Engineering Mentorship Program. And I had currently 4 students who actually work on this modeling issues for about 10 weeks. And we are currently continuing, and hopefully we could have some support to continue this actually next year. So just a moment, let me just make it a little bit bigger. All right, so what is the problem of this COVID-19? And engineers, we have to define the problem first, where people are infected seriously and then some of them die. That is actually the global health problem. And what are the symptoms of COVID-19? And the major symptom is new cough and loss of certain senses, taste and smell, and certain breathing problems. And those are primarily the symptoms. And there's other kind of side symptoms, but there are many. These less common symptoms are usually mild and gradual. So if you go to the CDC, then there is a very kind description of what would be the symptom, how you kind of make a self-test for yourself. And then are infected people are recovered? Yes. And what's been reported is that about 80% of the infected people, they are recovered without any hospitalization. And however, 20% of them has seriously kind of ill. And older people has a higher risk, obviously, because they are weak, but also the medical complication is another issue. And then, but in general, then anyone can be infected by COVID-19 and become seriously ill. The quick summary of COVID-19 pandemic situation is that where we currently have 7.7 billion the world population, and about 0.5% of them is currently infected. 34 million people infected over the world. And about 20% of them, which is like 7.2 million in US, they are infected. In Hawaii, that is about the 0.2% of US, 12,500 something people are infected. Honolulu data and the state of Hawaii data is quite similar to each other. So we actually pay a lot of attention for Honolulu instead of Hawaii state, because other counties, Maui, Kauai, and the Big Island, it could be somehow the noise data into Honolulu if we stick to the Hawaii, state of Hawaii data. That is about 1 million over the world, United States and 200K, and state of Hawaii, but a little more than 100, Honolulu 111. So if you simply divide this death number by case number, worldwide about 3%, US kind of close to, Hawaii kind of doing better job, although what's been doing for last few months are not that kind of impressive. And again, the state of Hawaii data, Honolulu data are kind of similar to each other, okay? So roughly saying that in the state of Hawaii or Honolulu County, approximately 1% of infected people died so far. And if you visit this site and every day, so 3 of my undergrad students are really busy between every day, 12 o'clock noon to like 2 p.m. They go to this site and actually get the data and update our website. I'll show you the website later. In terms of general kind of common sense, that we could just look at ask question whether COVID-19 drugs, are there anything available? Actually, there's no product approved by US FDA so far, but there are something kind of going on. So especially this one, the convalescent plasma, is somehow interesting that they took some blood plasma from the people who are recovered and tried to make it as a medicine for currently infected or who are currently seriously ill. But most of them are tried. However, none of them are actually fully approved, except few things that is allowed to use limited cases. So for example, this one, dexamethasone, and that is only for the patient who need mechanical ventilators or need supplemental oxygen. But most of them are kind of not proven, not effective. And also some of them, suppose like these two, are kind of one-time authorized, but withdrawn because it is found that there's a serious side effect. So far we don't have a serious, the significant hope to have treatment medicine or vaccine in any time soon. Okay, in terms of vaccine development, there are actually 6 phases. One before this phase 1 is preclinical, using animals as a test. It takes 3 to 8 years. And then phase 1, 2, 3, people use tens of people volunteered, hundreds or thousands. So those phase 1 to 3 takes about 2 to 10 years. And then the FDA start to let people use for this vaccine and limited purpose and or emergency only. That takes like 1 or 2 years, and fully approved, well, it also takes a certain amount of time. So minimum number 3 plus 2 plus 1, 5 year or 6 year is automatically kind of minimum number of years to have one safe and reliable vaccine. So I'm not sure what we have to recognize by the media that certain vaccines will be available pretty soon, but it could be. However, there's certain risk that we actually have to take. And recent New York Times report says that researchers are testing 43 vaccines in clinical trials, which is before the phase 1. And then at least 91 is somewhere in this phase. But even if so, then we actually have to wait a few years. I just want to go over some kind of basics of how vaccines are kind of made and released every day, because the flu vaccine we're going to have, let's say this year, is a future event. We have no way to know what kind of viruses will be a few months later. Then how come these pharmaceutical companies make a vaccine and spread and just make it available for the public people? They just use surveillance data and try to make the best forecast. So technically, it is the applied mathematics, the probability problem, which vaccines, which virus is gonna come up in the incoming seasons, and what would be the most effective vaccines that we could just release today. So again, the vaccine and virus is kind of the probability game. And there's a very, very interesting kind of study a long time back, 2005, in journal named Vaccine. So here, if you study the kind of chemistry, there's one called the stoichiometric kind of reaction, A plus B reactant A and B reacts each other and make C. So these people use exactly the same method. So y-axis is more likely how effective your vaccine to a certain kind of viruses or disease is coming up. And then P is mismatch probability. So if your vaccine is perfectly mismatched, that is actually 1. Then this vaccine is no use, not effective. So you take your vaccine, but there's no effect. You just get sick for a few weeks and then you recovered. If mismatch probability is 0, then the vaccine is perfectly kind of matching to disease and you could be fully immunized. Then actually this is very high. The problem is if your vaccine is half working, then your immune system, your internal immune system is kind of confused and take a longer time whether the new antibody will be generated or use the old one. So that means you are kind of chronically sick for a long time without just any better symptom. Let's go back to the history. In the 14th century, there's one called the Black Death, and we call the pestilence or great mortality or plague. Yeah, plague is the one kind of commonly used. And this one occurred in the 14th century of Europe, and it killed 75 to 200 million people. This is kind of very scary kind of happening in history. Back in that time, there's no vaccines and there's no kind of medicines. So therefore, this many people probably amount, back in that time, there's no the global census. So people do not know what exactly the world population is. However, these one people expect that probably 25 or 30% of European people died because of this pestis called the plague. And this is kind of a famous figure named the Triumph of Death, 1562. So probably you can just go back and see what happened before and to get the better kind of lessons or plan better what our future is. Okay, the name is also important. I was wondering what does COVID-19 means, and it is officially named like CO from coronavirus disease occurred in 2019. So December 2019, and Chinese authorities, and they kind of observe certain patients clusters are having some new disease, very similar to the SARS. Severe acute respiratory syndrome, which killed less than 1,000 people in year of 2002 and 2003. But actually, COVID-19 is kind of one species of this, one of the 7, but this is more kind of a drastic. And also, we don't have any kind of treatment medicine or vaccine. But this one, MERS, is one and hits the Middle East known as the Middle East respiratory syndrome coronaviruses. So, well, bioinformatics people, and they pretty much know the gene sequences and almost all kind of information of the coronavirus species, but we just don't have any vaccine or treatment medicine right now. So if you look at any paper, kind of science, regular science paper, people use COVID-19, but I heard that doctors, they kind of discriminately use the SARS-CoV-2. Timeline know-how. So this is what my students made, and I'm very proud of showing this. But since I have to show some detailed information, let me just use a table. Yeah, old people like table better than graph anyhow. Okay, so January 20th, first US COVID-19 case was reported. That is actually about 1 month later, probably 3 weeks later after the Chinese government released this information, Wuhan virus. And then up until the mid-March, then we don't have anything very specific, especially in Hawaii. It was very kind of almost nothing. And then in here, then Hawaii public school closes, and then March 25th, and Hawaii stay-home order started. And then that one ended in May 31st. So approximately for April and May, little more than 2 months, we have this stay-home order. One thing that happened in timely manner, but in bad way, is this one. I'll explain why. April 15, the stimulus payment started from the federal government. And then I'm very suspicious that that one is well mismatched in terms of time with the stay-home order. I'm just gonna give you the clue later. Okay, and June and July, there's nothing serious in August. And then recently, the late August, then we have 2-week stay-home order where state of Hawaii government were kind of hesitating, but they just have a media release few days and they finally decided 2 weeks stay home. But one thing that is scary is that passing July and starting August, the Hawaii has drastic increases in number of confirmed cases. We are very scared and we actually do not know what to do. Well, there's no clue that we could forecast or analyze because we have very limited amount of information. So now we are, as an engineer and planner, we should kind of make a certain boundary or bound the problem. So now we can think about the best and the worst cases. Best case, someone make a treatment medicine tomorrow and everybody can use it. Then we don't need to worry about anything, very, very naive start. But the worst case is that, well, we have, since the ratio of CCD, cumulative confirmed death to cumulative confirmed cases is about 1%. And then we have total population of 1.4 million. So you simply multiply these numbers, that is actually 1,400. So very worst guess or kind of imagination is if everybody in the state of Hawaii infected, okay? And then we have this much percentage to the death, then the pandemic situation or this disaster will end with 1,400 people died. That is actually the kind of extreme and the worst scenarios. But technically, the WHO, they kind of do not know what will happen. Yeah, the head said, well, this coronavirus pandemic could be over within next 2 years. He said in the mid-August. However, it is hope, not just guarantee or expectation or anything, which means it will be obviously more than 2 years. And we actually have to prepare our personal plan as well as education plan better, starting from today. My personal interest that actually started from this data. So technically, I was interested in, first of all, is this pandemic situation globally unique, globally universal, or different, like country by country? So I have a hard time to find out, kind of selecting the representative countries. So probably the G20, Group 20 would be the best example. In G20, there are 19 independent countries, and then one of them is actually the European Union. So European Union is not a real country, so I excluded it. So technically what happened is that here is a data about 6 different European countries: Germany, France, Turkey, Italy, Russia, and UK. Yeah. And if you look at this one, this is the linear and logarithmic plot of CCC, cumulative confirmed cases. And then this is a death number from the starting date of death. That is linear scale and log scale. So actually, I found a certain mathematical transformation, okay, that I could somehow merge the 6 graphs into one single line. Yeah, well, how? Well, for example, you have this blue line, then you move this blue line to the left, and then try certain transformation, very, very simple transformation. Then I was able to make this one single line that all the 6 European countries CCC data converges to. That's as well. And in this case, we have actually way more. This is 6 countries, and this is actually 19 countries. And again, initially, it all converges into one line, cumulative confirmed cases, and this is cumulative confirmed the death. So this one is actually published as a preprint in the media archive, and you could kind of download it and take a look at it. Okay, so amazing thing is that, oh, but this one looks likely very, very scattered, and seemingly they don't have any correlation. But based on simple transformation, we have universal law. Then probably this law or kind of governing line could help us to prepare our future by more accurately and reliably predict the confirmed cases or confirmed death. Let's see how Honolulu CCC cumulative confirmed cases or infection number, total infection number data changes with time. So actually 0 indicates the first occurrence of a case in Hawaii. That is March 7th. Okay, so from March 7th toward the mid-June, and it increases, well, kind of stay, and then increases and go back to some constant value. So technically, I was asking to my undergrad students, what kind of function do you expect to fit this data? Well, quadratic, blah, blah, polynomial, but one of the things that if you do some neural network thingy, then sigmoidal or tangent hyperbolic is, or even step function is kind of perfect match. So we start using tangent hyperbolic function, but the fitting is really good. So we're so happy. And so the COVID data looks very complicated, and some of my undergrad students, they were very, very successfully fit this initial first wave data using a simple, very, very simple tangent hyperbolic function. Okay, good. Now we just keep monitoring this data. And then near late July, we kind of expect that this second wave will follow green line, and similar to the first wave trend. So second wave could be kind of inaugurated or increases the function of the first wave, but what it turns out to be is totally different. Here, it suddenly increases. So what I said at this time is that this is onset of the third wave, and third wave initiated before the second wave ended. So here, if you look at the current data, and second wave almost disappeared because the third wave is very, very large. And then you're just gonna keep going from August 4th and keep increasing. And please take some attention that this maximum is 5,000, and then keep increasing. And then also keep increasing. So at this time, we were using like 4 to 5 different different fitting equations, and then we are in a really panic that nothing is working fine. So similar to the Olympic game evaluation, that we just get rid of the lowest and highest value, or we just make a kind of ensemble of models. But even that, it was very, very hard to predict what's going to happen in the next two weeks at this time. Okay, and again, it continues the August 10th. So this trend is actually very, very scary. And if the Honolulu confirmed case profile still follows this line, then by the end of this year, that we actually reached a very, very large number, about 100,000. Right now, we just a little bit over 10,000. But if this trend continues, then it'll be easily reach the 100,000. Okay, yeah, this is kind of revisit, and remember that this number is 5,000. And this is actually the today's data, October 1st. I made it actually technically today, early in the morning. I mean, late night. So Honolulu, state of Hawaii, Honolulu and state of Hawaii data is almost same. And it already exceeded 10,000. Bam. Yeah, but if you look at this closely, that is sort of interesting that you have a very standard tangent hyperbolic function low in here. And then second one may started, but in the middle of this second tangent hyperbolic, we have almost linear increase. Okay, this is a linear scale. And then somewhere late August, this curve, a linear trend just make different slope. So one steep slope and kind of a little bit gradual slopes. So how do we kind of interpret it? So right now, at this phase, I was so paying a lot of attention. How are we gonna predict the number next week and next month, or even toward the end of the year? But right now, the timely forecasting is not that important. Yeah, I'll explain why. So this is actually the here. This is the one that we have, and this is actually only for the latest, probably about 1 or 2 months, and still it kind of shows so weird. So I don't think that this pattern fully fit with tangent hyperbolic, but looks likely there's some exponential growth came up, but linearized, and then we have certain, I don't know why, but certain transition between these two slopes. So it is not that possible for us as a applied mathematician to predict these kind of curve slope changes, but we actually have to look at all different kind of socio-economic events and how humans are behaving within the state of Hawaii. This is log plot. The log plot is way more kind of transparent. So you have a first wave, and then second wave started, and third wave. So if I didn't explain what the second wave started in here, and you didn't look at this profile previously, but look at this one today, then probably you can easily miss the second wave. So we have first wave, and this one looks likely the second wave. But second wave started, and then the third wave was initiated on top of in the middle of the second wave. So when the first wave comes up, this tangent hyperbolic function works really good. Fine. And then when passing the late July and the early August, then actually this model is not working. So I actually have to use the 5-day linear regression or 5-day local linear regression. Okay, one of them, and it worked a little bit better. But well, as you know, that calculating these coefficients using Excel, well, statistically important. However, it doesn't mean anything too much. So since I'm physics based and then I teach dynamics, and why don't we just apply the engineering dynamics model for short term? So daily confirmed case, well, the duration is every day. So daily confirmed cases can be considered as instantaneous velocity. And the cumulative confirmed cases could be considered as a traveled distance. And then you just difference between two consecutive days. Daily confirmed cases could be treated as acceleration. So this model works kind of well, and where their linear trend is somehow not kind of convincing, especially nowadays. Recently, that the increasing rate is decreasing. So in that case, this dynamics model works better. So we actually have made this website, highcovid.net, and about a month before that we shows up in HNN, Hawaii News Now, yeah, as a student project. So technically, this project is supported by NHSEMP, the Native Hawaiian Science and Engineering Mentorship Program. I'm very proud of the 4 undergrad students who actually worked on. But technically, the mathematics level that we are doing is not that advanced. It is simply slightly advanced level of how to use the Excel for a little bit better the statistics. Here, a different way to look at the data. So I just calculated number of days, calculate the mod. So mod 0 means Sunday, mod 1 equals Monday. So if you look at this one, then you don't need to have a long data, okay, because it's kind of periodic. So at this phase in the middle of August, that weekend and increase is better than at the beginning of the week. So Monday and Tuesday, the increasing rate is slow, but near the Saturday and Sunday, it increases kind of a little faster. But right now, that one doesn't mean too much. But it just says that the pandemic data has 7 days of periodicity because people live in weeks. So just want to emphasize that the Honolulu data and Maui data are kind of similar to each other, except this one or two kinks. So the reason I didn't pay too much attention in Maui, Hawaii is that their population is smaller and then their CCC numbers are small. But if we mix them together, then we have Hawaii data, state of Hawaii data, but it would somehow, we lose some detailed information of Honolulu. So I still focus on the Honolulu data only. Although I did this Maui case because one of my friends in Maui, he twisted my arm. And Albert, you gotta do this. Okay, I'll do it. Right, so this is one of the representative plot among the counties. So blue one, actually the plot is 7-day increase. So we just add how many cases increases in last 7 days. So it's kind of sum. The number is not that kind of important as it is, but trend. The blue is a Honolulu trend. And then, yeah, the red is Maui, and then the green is the Big Island. So as you can see that when Honolulu is on peak, it takes like 1 or 2 weeks that other counties have peak. Okay, so Honolulu peak is always advanced than the others. So probably this is a kind of indirect kind of clue that the state officials and any policymakers in 2 different counties, they can just look at what Honolulu are doing and make a better choice or think about something new or more adjustable for their own county. Yeah, actually this is similar to what we are doing right now. So in most of the aspect that we look at what California and New York is doing right now, and we can actually have more time to apply any kind of method to safely apply to the state of Hawaii. Okay, so let's look at the social science data a little bit better. So one of, when I make this website, and one of the realtor, kind of retired realtor just contacted me, and he just coached me a lot because he knows almost every business in Hawaii. He is kind of early 70s or something. His name is Clark. And then I got this data, actually website. So here, all consumer spending, here's January to October 1st. So March, towards the May 1st, yeah, this is May 1st and this is mid-March. And it seriously went down and then grow up. But the key point is that we almost recovered spending in here. But even that is higher than, actually 10% higher than what we did before the pandemic, or probably the last year. So let's just hold on this one. And then this is small business revenue coming down in March, April, and slowly recovered. But again, this recovery is somehow negligible compared to previous one because it didn't fully recover, but a little bit, almost not. This is the number of small business open. Well, trend, this one and previous one are kind of similar to each other. So from zero is kind of normal, and then it 50% decreases and recovers like 20%. So we are somewhere in the negative 30%. This is job openings, similar. Yeah, so here we have 0, and we had more job openings in before March. Probably the year started and they have more openings, but it seriously declined, similar to other two, but it never reached the same level, because this is 0 and that one is 20, 40. So we are somewhere in the negative 30%. Percent change in employment. Well, it's very, very well expected. Then percent change is 0, stable, and then seriously declined March and April, and slowly backed up 20 or 30%. But interesting part is that this one, just remember this graph. And then the next one is unemployment claims. So if you look at this graph and previous one, what coincide, oh, I made too much. Yeah, this one, then probably the negative slope of this curve would fit very well with unemployment claims. Okay, so that makes a lot of sense. So you have a lower job, and then the unemployment claim request would be proportional to how fast that jobs are kind of lost. This is the daily reported COVID-19 new cases. So peak is somewhere in September 1st, and this peak goes on. That is actually most likely July and August. And passing August, we just going down, and probably this is due to the latest lockdown order for 2 weeks. But one thing interesting is the CCD, the new death, and the previous one, new cases, are kind of similar. And I was expecting that this death was a little bit behind in terms of time lag, but looks likely they occurs in simultaneously. And then why we have more cases? Well, someone just claimed that because we tested more. That could be true in one sense. So we don't know how much this test number increases or influence the increasing number and the infection cases. Still need more kind of detailed research. And next 3 is a cumulated one. So this is total cases, meaning that cumulated confirmed cases gradually increasing. The reason I pay a lot of attention for this total cases, or CCC, cumulated confirmed cases, is that the data is very smooth. Because this profile is more likely the cumulative probability function, and previous one, daily update, is like just the probability function. So this total cases never decreases. If everything stopped, then it will stay and the constant. So it's way easier to model. And if you differentiate this curve at any moment, that is nothing but the new cases on that day. So it's way easier mathematically. And this is actually deaths. Previous one is cases, and this is total deaths, similar profile. And also this is a cumulative total test. Well, it looks likely linear, but slightly exponentially increasing. So we saw 12 different graphs, and altogether it looks very random. So one way is that where someone look at this data one by one and try to find out any clue, and maybe the data scientists, smart people, can just run a certain program to find out something that we couldn't see right now. But the interesting thing is that in this column is cumulative cases, death, and test. Looks like very correlated. And this one, third column, is daily new cases, death, and test. Well, I can say that these are uncorrelated, but I don't think this is directly correlated. So someone needs to help us. But other things are kind of similar. So you have this 1, 2, 3, 4, 5, and that one is very correlated, this one. But if you look at these 4, decreases from 0 and then recover some, decreases from 0, recover, same and same. But that one, total spending is only one, is kind of different. If from 0, sudden decrease and gradual increase, and it actually over the 0%. So in last 2 to 3 months, and people in Hawaii, especially Honolulu, they spend way more than they spent before March or last year. So if you compare these two, what happened is that March 25th, the stay-home order started. That is actually this box line, left-hand side. And at the end, June, May 31st, this line within this box, the stay-home order ended. In the meantime, in the middle of summer here, the April 15, stimulus payment started. So what I could just reasonably kind of make a certain guess is that people were unemployed, and then they were forced to stay home, and then they got stimulus payment check. And then that money is kind of accumulated and spent in this period, which is June and July. That may be highly correlated. So this excessive spending may be correlated to this very, very steep peak in total cumulative cases. Okay, let me just spend a few more minutes. Comment is, this is what I just explained right now. And then what will happen to Hawaii and Honolulu in the near future. So this is a good story. So we kind of know how the CCC increases, and then we already know that this number, total cases, exceeded 10,000 in the state of Hawaii. Okay, so what do? We kind of know almost everything roughly, although we don't know in detail which one is the most important factor that we actually have to consider as a precursor of any kind of drastic increase. We roughly know almost everything, very roughly, not in detail. However, so what do we do for the future? So that is the time that we actually try to use one of the two methods. One is numerical modeling or standard forecasting. No matter what you use, the linear regression or deep learning, well, this is the category that we are falling into. Second case is benchmarking to other nations. Let's look at what other nations are doing, and can we have any kind of useful information or implication that we could take? Well, that would be kind of zero cost meta research. Yeah, in 21st century, this meta research become more and more important. So let's look at the similar places. This is Hopkins data. You just go to, and the beautiful GUI interface. Sometimes it's kind of slow because graphics are heavy. Malaysia, as of yesterday, they have this many cases, and then increasing. Okay. And then Slovakia, this many. And this increase is way more than, so probably they are kind of experiencing kind of similar thing that we did in July and August. Namibia, in one of the countries in Africa, increasing, and their number is over 10,000. Montenegro, yeah, increasing, about 10,000. Congo, even Congo, it increases. Well, probably this is really good for using the tangent hyperbolic function, but point is, it is still increasing. So lesson is, tell me any nation or territory in the world among the 206 nations and territories where their CCC, cumulated cases, exceed 10,000 and stop increasing. There's nowhere in the world, which strongly implies us that, well, our infection number will continuously increasing, linear scale, but be ready for it. Yeah, that's why I put more attention to the data correlation instead of forecasting. Future forecasting, unless we have a more serious wave or unless we have some great medicine, it would be very, very similar, kind of gradual increase. Ongoing research is, well, this is time that the social science, economics, and applied mathematics and all different scientists kind of marry and then provide more holistic analysis in addition to, as compared to the simple forecasting. It doesn't mean too much. Well, you just throw the CCC or CCD curve, and even like middle schoolers and high schoolers can just draw the trend line. Well, that's almost all that we have, because where the modeling that we have, like SAR model and different models, are fully based on exponential growth and decay, although there are some extra terms in there. So solving PDE to predict future pandemic situation is not that advanced enough for us to give any kind of comments or suggestion to politicians or policymakers. This is a link that I just collected. So I'm gonna send this file to the Guan, and she can just share. And then my beautiful undergrad students, and there are a few more people who voluntarily donated a few $100s, and who just gave a lot of good comments and show me the link that they found and articles. So I couldn't write them all together. If I do, then probably 100 people that I have to list. But initially, this research is initiated by my own interest, but it is boosted through this program summer and my undergrad students. Yeah, I think that's it for today. Thank you.
Hey, thank you. Join me in thanking Albert for a great seminar. We have plenty of time for questions. I think either just unmute yourself or raise your hand if you have a question. Let's see if we see it.
Hello, I do have a question.
Okay, yes, please go ahead.
Hey, Dr. Kim. I have a question regarding when you do structure a model for forecasting our Honolulu data.
Mm-hmm.
So what if you were asked to include the demographical data? How would you structure the model again?
You want me to explain the algorithm part?
Now you're just treating all the CCC the same, but based on different demographical statistics. So we can definitely separate them into a subset and to deal with independently. Do you think that makes sense, or it doesn't matter because it's all just raw data?
Okay, thank you so much. Yeah, we have a big theme. Yeah, how are we gonna serve this pandemic disaster? And then we could make 1,000 branches under it. So you have a first tier, second tier, and fifth tier. So it's more like a bifurcation process or bifurcation tree. So what you said is very meaningful. So we actually have some graphical data that which region, like EVA or YNA or Kaneohe, they have their own kind of numbers that showing in graphics. Sometimes data is available, sometimes data is not available. And then we start from this world as a globe, and we classify the nations into continent. Within continent, there are many nations, and within nations, there are counties and small counties and villages. So this is really actually analogous to the statistical physics or thermodynamics. There's one called the renormalization technique that handle this multi-scale phenomena at focusing on each. So technically, what I can suggest to natural scientists is that we actually do not need to develop any new model for COVID case. Well, because we don't have enough data. This is a one-time happening. So if you want to make model, then you need to actually calibrate it, but we don't have any enough data for calibration. This is first time. Therefore, it is way better that you look back to the applied mathematicians and theoretical physicists did in 1970s until 1980s. And there's a bunch of different theories that you could directly apply and to make meaningful suggestions. Yeah, so data preparation is another issue that we actually may have to standardize, and different websites provide different forms of data. So that is probably the data scientist or programmer's job, and not mine, and I'm not able to do it.
We have another question from John. Can you elaborate on how this type of historical analysis actually helps our current and future situation?
Historical means the what happened this year. Yeah. Well, let's see. So only thing that I can say is that, well, from, let's see. Yeah, maybe one of them would be good enough. Yeah. So I show this graph as of October 1st. But from early March until now, my opinion changes 100 times. Yeah, you look at one-day data, and my hypothesis or whatever analyzed yesterday looks likely inaccurate. So the one thing that I want to emphasize about this research is it's a real-time research. That is kind of big difference between the previous one. So although we kind of use the historical data, so this is past data, and the data will be updated today, tomorrow, and so forth. But this is a real-time computation. So looking back to history is a good enough. It's important to forecast the future. But the thing is that you don't need to know this data too much to predict the future, because it is always like instantaneous increase and decreases. So in my opinion, I stopped paying too much attention for these forecasting numbers, but I will pretty much start what are the key factors or precursors that we could somehow predict the future data more accurately. In other words, you forecasting the later data using this one time series is not enough.
Okay, great. A question from Paul: Are daily cases, hospitalizations, and deaths available for download as a spreadsheet? Is that data available?
Yeah. So what the data that we use is quite limited. So far, we use only global data. So European CDC release everything. Yeah, and they have like 206 countries and territories for all over the world, and you could just download it and make your own plot. And other than that, the Hawaii CDC has updated data for Hawaii. So confirmed case and death are only one that we are doing right now, but we are kind of making a plan to which data that we kind of include and run kind of better advanced modeling. Those includes the one that I showed you today. And also one thing that we're gonna include right away is the transportation data. Yeah, Google and Apple has the big data available right now. So you use Google Map, then you want to go somewhere, then you actually kind of search and how fast it is, and those data are available from Google. And then the mobility data, which I don't clearly understand right now, and also state of Hawaii, the Department of Transportation, they also release certain amount of data. But another problem is that these data sets are not as well prepared as the confirmed cases and death. It's kind of scattered data that you actually make your own script, or there are certain kind of blank spots in here and there. So getting data and then classifying very strong correlation data and also analyzing them is kind of a long way to go. And then if you look at the NSF news, then they recently supported 60 new the startup companies to handle the COVID data as a new company. So there is certain opportunities, but personally, unless you are very well prepared as a data scientist, then the market is already red. This market was very blue in the March and April, even the paper submission, but right now everybody jump in. So my strengths, or not the strengths, the difference, make your own one different is localized one. Yeah, again, the confirmed data, confirmed cases and death data is not enough. We need to find out any socioeconomic time series and human behavior time series, and then use them and try to explain why we have a certain plateau here and why we have certain increases. So this is actually really a convergence or consilience research that social science and natural and applied scientists, we just get together and find a better idea.
Great. Okay. Tom Blamey, did you have a comment or a question? You there, Tom? I think Tom's comment was that Albert's work helps.
Team, my wife's on one Zoom behind me. It's terrible cross traffic. Thanks, I'm part of HiPAM, and Albert's come in and talked to HiPAM before too, so it's fabulous to have him.
Okay, awesome. So I think we have time for one last question from 112. How do you select the modeling approach? Could you please explain more?
Okay. Well, how do I explain this one? So when you try to solve the new scientific problem, and then number one, you observe, and number two, you kind of simplify and identify what real problem is. And probably number three, you make your own hypothesis. Then how do you make your hypothesis? That's your personal choice. Yeah, so I have a theoretical physics background, and I love engineering topics. And then it just one day, it hit my head. Oh, well, this function looks like the one that I learned before, like in my undergraduate period. Yeah, so how do I select? It's, in a fancy word, it's intuitive, but in kind of frank words, and it is based on my previous education and background and experience as well.
All right, well, let's see. All right, well, thanks everybody. It was a really great seminar and wonderful discussion. Thanks again for attending. If you have one moment before you take off, if you could fill out our optional demographic survey. We use that for all of our reporting, all that. So, but great way to end the week. Thank you, Albert. Thanks
so much. Okay, bye.